Welcome to Class Champ Boot Camp with Coach Harrison. Today, trainings will be able to solve two-step equations. Let's go! Alright class, so hopefully you've already completed the do now and the skill builder. We're going to start working on the guided practice. Let's look at question number 1. -9 plus d equals 7. So I see that this equation is not in standard form. I'm going to begin by writing this equation in standard form, putting the variable with the highest degree first, and using the commutative property to rewrite the expression. Now, remember when solving equations, your main goal is to isolate the variable. D is not isolated because it's being added to -9, and so I need to get rid of this -9. In order to get rid of -9, I am going to add the opposite. So the opposite of -9 is +9. I have to add the opposite to both sides of the equation in order for this equation to be balanced out. Now, what do you notice after I've added the opposite? Right. By adding the opposite, we formed 0 pairs. So -9 plus +9 is equal to 0. I'm going to bring down D. The -9 and +9 cancels out because it's equal to 0. And 7 plus 9 is 16. So D is equal to 16. I'm going to now check my work to make sure the solution works. When checking my work, I plug my solution back into the original equation. We found that D is equal to 16. And so now I'm going to rewrite the equation and then replace D with 16. And then I'm going to see if that checks out. -9 plus 16 is 7. Because the signs are different, I would have to subtract, which would give me 7. And because the positive sign has a higher magnitude, my answer is positive. So in this equation, D is equal to positive 16. So for question number 2, we have 3 equals 14 plus t. I'm going to flip this equation because I'm used to the variable being on the other side of the equation. And when I flip it, I get 14 plus t is equal to 3. I also immediately noticed that this equation is not in standard form, and so I'm going to rewrite it using the commutative property because it's already an addition sentence as t plus 14 is equal to 3. All right. Now I am going to isolate t by using the inverse operation. So in question number 1, I isolated D by adding the opposite. For this question, I'm going to use the inverse operation to isolate t. So the inverse of adding 14 is subtracting 14. And if I subtract 14 from one side of the equation, I also have to subtract 14 from the other side of the equation so that it stays balanced. We still form our 0 pairs because positive 14 minus 14 is 0. That cancels out. And now I'm left with t is equal to 3 minus 14. I'm going to use KCC, keep change, or add the opposite or the additive inverse to rewrite this expression. And now I have t is equal to 3 plus negative 14. Well, 3 plus negative 14 is negative 11. We subtract because 3 is positive and 14 is negative, and when the signs are different, you find the difference. Because a negative sign has the higher magnitude, then my answer also has to be negative. So t is equal to negative 11. We do see the solution here for B, but before I select B as my answer, I still need to check my work. So let me erase this. So I start off by writing the original equation, 3 is equal to 14 plus t. I am then going to define my variable, t is equal to negative 11. And then I'm simply going to replace or substitute t for negative 11. So I write the equation as is, but instead of writing t, we know that t is equal to negative 11, and so I'm going to replace or substitute t for negative 11. And then I see that 14 plus negative 11 is still 3. That checks out correct. So give myself a check mark. The answer is B. Okay, so now let's look at question number 3. 1 and 7/10 minus p equals 3 and 5/10. Well, I'm first going to write this equation as an addition equation. So 1 and 7/10 plus negative p is equal to 3 and 5/10. I now have to write this expression in standard form. So instead of 1 and 7/10 plus negative p, I'm going to write it so that the variable is first. Negative p plus 1 and 7/10 is equal to 3 and 5/10. I see that I need to isolate the variable. So I have negative p plus 1 and 7/10 equals 3 and 5/10. And I notice that the 1 and 7/10 have to be removed. In order to do that, I'm going to add the opposite. So we see that 1 and 7/10 is positive. I'm going to add the opposite of positive 1 and 7/10, which is negative 1 and 7/10, to both sides of the equation. Okay. What happens when I add the opposite? Well, a zero pair is formed. Now we have 3 and 5/10 plus negative 1 and 7/10. I'm going to simplify that. But first, before I simplify, let me just bring everything down. The 1 and 7/10 and negative 1 and 7/10 cancels out because it forms a 0. So I don't have to write the 0 there. I'm going to bring down negative p. And then 3 and 5/10 plus negative 1 and 7/10 will give me positive 1 and 8/10. The question then becomes, is P isolated? Is the P isolated? I'm going to give you 3 seconds to think about your answer. Is P isolated? No, it is not. P is not isolated because that negative sign is still there. So I'm going to make the coefficient explicit by putting the 1 in front of P. And then I'm going to divide both sides by negative 1. The negative 1 cancels out. And because I'm dividing 1 and 8/10 by negative 1, my answer is no longer positive 1 8/10. It becomes negative 1 8/10. So P is equal to negative 1 8/10, because a positive divided by a negative is a negative. Now we're not done, because the last step is to check your work. I'm going to write the original equation, define my variable, and now I'm going to plug negative 1 8/10 back into P, or substitute negative 1 8/10 back into P. All right? So I have 1 7/10 minus P, we found out earlier, is negative 1 8/10, is equal to 3 5/10. Use KCC to write this as an addition sentence, and now I have 1 7/10 plus positive 1 8/10 is equal to 3 5/10, and that's correct. I can do the math on the side, but I know that 1 7/10 plus 1 8/10 is actually 3 5/10. So I'm going to erase this again. And I get P is equal to negative 1 8/10. Now let's do question number 4. For question number 4, we immediately notice that it's not written in standard form, and it's a subtraction sentence. So the first thing I'm going to do is write this expression as an addition sentence. After I write it as an addition sentence, I can now use the commutative property. When I use the commutative property, I end up with negative F plus 12 is equal to negative 5. I now want to get rid of the 12, and so to get rid of the 12, I'm going to use the inverse operation. You can also add the opposite, but I'm just showing both methods so that you can have a better understanding of how to use either the inverse operation or adding the additive inverse to isolate the variable. So here I'm going to use the inverse operation by subtracting 12 from both sides. (12 minus 12 is 0. I bring down negative F. And I also rewrite the expression. So I have negative F is equal to negative 5 minus 12. Well, negative 5 minus 12 is the same as negative 5 plus negative 12. And so negative F is equal to negative 17. However, we notice that F is not yet isolated because of the negative sign. So I'm going to divide both sides by negative 1. The negative 1 cancels out, and my final answer is F is equal to 17. However, I am not done yet. I always go back and check my work to make sure that this solution is in fact true.